before it's annoying.
It makes people think we're going to a lockdown.
So, yeah, I didn't think about that anymore these days. So, morning, folks. I'd like to interrupt our regularly scheduled lesson. See, there's a joke in there. To talk about a current event in our science. All right. Back in the days when people watched TV, you would get that horrible noise coming across, and it got your attention. Nowadays, it comes through on the cell phone, right? And that's kind of cool. Still scares the hell out of you. But and then this is an even older one. I think it would make the same noise. I don't recall. I'm sure they showed these in the early 70s, but I don't remember seeing this one per se. But at any rate, so we're interrupting today, of course, to talk about hurricanes. All right, and I'm not sure this is the latest in the semester that I've ever had to do this. I do know that usually it happens very early on. I don't think we're a month in yet, but we're getting on there. At least 3 weeks. Before I want to start with the lesson proper, I do want to stop and look at the actual reason for what we're doing here. Hurricane Helene, as you've probably heard if you're paying any attention whatsoever.
Holy crap, that's going way in.
And I've been paying attention to it for a little while here. They must have had some inkling that it was going to be a problem. Because these trackers, these actually start, and I'm sure they were tracking before I picked up on it, but 3 days now, it's still off the coast of Cuba. So it hasn't even hit land yet. It was supposed to hit by this morning. Now, parts of it, something called the rain bands, and you'll hear about those in a little bit. The rain bands are obviously there, but the main portion of the storm itself has still to come. And I'm not a fan of the media. The media these days is all about sensationalization and so on and so forth. And, they got to keep you occupied 24/7 now on these news channels. So they got to talk about something. I suppose it's a welcome break from the election stuff. But not for the folks that are living down there through all this. But one of the things that's been, and I get these updates because, I do, is how the hurricane, its track has been changing. All right, these are projections, right? And this is a problem we have with science over and over again. They're not like yelling at the meteorologists, thank goodness, but they're announcing like every time they post a new diagram, they're announcing it and saying, "Oh, they're projected to change." Well, yeah, but I guess again, the normal populace doesn't get that, you're dealing with a force of nature out over the ocean that's going to do whatever the hell it wants to do in the long run. But I think constantly updating it is just, I don't know, it's just feeding this anti-science thing that's been going for the last handful of years. I'm not horribly fond of it. In reality, and this is what I kind of wanted to show you here, it's not changing that horribly much. This one goes back to the 24th. And you can't really see probably from where you're sitting, but these are pretty good. I don't want to say good as in accurate predictions, but they're putting a lot of detail into it. We've got letters here. S is for storm, I'm gonna say. I saw it somewhere. It's for wind speeds. Okay. So S is for tropical storm, H is hurricane speed, which you will learn soon. It's over 74 miles per hour. And then M, I'm not sure if it stands for massive, but probably major. Okay, that's over 110. And then you see where it goes back down to S. And then D is Yeah, thank you. Yeah, it's in there somewhere. Which still, if you got almost 40-mile-an-hour winds coming through Utica, that's something, especially if it's raining too. So yeah, as he said earlier, holy cow, this sucker's moving inland. It's not like you've never had hurricanes up here. I was asking you before class how old you guys were in 2011. That's one we're going to talk about later. All right. So anywho, so there's the initial projection, and you see how this is really just that, a prediction, a projection. As we move into the next day, it gets a little better and much more so, much less fuzziness as to where they think it's going to go. They don't point that out. They just say that it's changed again. So these scientists changed their minds again. Well, if you actually look at the data, which nobody does, we've essentially coming inland at about the same point. All right, and it's really just what happens to it after it hits land. Which is a whole other thing. And now we got this one. This is of this morning. You see there's a much narrower. Let's see, have they been changing that one all along too? Yeah, see the band is getting smaller. And that I do recall I saw reading about. So the actual where it's hitting, they're getting more specific. All right. So as this data, and as I said, the dang thing still hasn't hit. So here's Cuba down here, Florida, obviously. All right, so that's that. Then also I want to look at so let's do the bigger one first. I guess it's this one. There we go. So here's what we're looking at if we just look at the East Coast altogether. And you see, holy cow, it's already, raining like crazy down there. And here's our little weather that just came through. But remember, we're off the coast of Cuba, so you're looking at this down here. And you're like, oh, that just looks like any of this rain over here or any of this other rain. And we zoom in a little more. And you see that it is just still green and yellow. There's nothing too horrific in there. One of the things, and if you watch the weather, you always hear, we don't worry about hurricanes up here so much, but about tornadoes. And one of the things the weather folks are always talking about when we worry about tornadoes is they see that comma shape. All right? They're seeing rotation. And right there we're seeing some rotation. Still, I don't think looks, too horribly threatening, especially to, Joe and Jane Normal out there in the world, which again, you guys aren't anymore because you're taking geology and or earth science. But when we switch to that, all right, that looks a little scarier, I think. First of all, we're trained to not like those colors, right? So, yeah, there's definitely something going on. I had the bigger thing up here. Let's see if it'll start moving again. But no, it's not going to zoom out for me. Why are we froze? At any rate, so I talked about the rain band. So you see how the front of the storm is, Florida's kind of obscured by clouds at the moment. But you see how the rain bands are already hitting them. We're talking about evacuations and so on and so forth. Folks down there, different sort of folk, okay? What would send a lot of us running to the hills or whatever you want to say, they're going out and buying an extra case of beer, a bottle of wine, and some chips. And, you get used to it. There's so many times it's kind of like the sky is falling kind of thing, boy who cried wolf kind of thing. And it's not that horrible things don't happen when these things come through. But I think, did anyone grow up down there and go through hurricanes? These are just observations I'm making. That it's, what are you going to do? You're going to leave town every time a hurricane comes through. So I think when they're in the rain band areas, they really, for the most part, most folks just stay put. Now give them, half an inch of snow and the world's coming to an end. So you guys deal with different things up here. But regardless, they don't freak out quite as much. That being said, let's get back down south here. That being said, when you're in the, why are we zooming? Oh, there's a beautiful view right there. Screenshot. That being said, when you're in the path of the eye, in the main part, they do, I think, for the most part, take that seriously, and as well they should. But yeah, this is projected to be a pretty big one. We've got, I don't know, 6 hours or so. It's moving pretty fast. It's hard to tell mileage here, but before that, it might be this evening, 8 o'clock maybe. We'll see. Till that sucker actually makes landfall. So do what you do, say a prayer, fingers crossed, whatever, that folks down there are okay. So what actually is a hurricane? All right. Well, despite all of the negatives we just said, they're kind of works of art. Isn't that a beautiful picture of a cloud? I mean, that's just amazing. To be underneath that at any given moment, not at all the same. But yeah, that's just about a perfect picture. You see, what do we call that in the center there? See that kind of dark spot there? That's the eye. Right, let me get my mouse here for the folks at home. Right, there's the eye. And this thick area right around there, we're going to give that a name eventually too. All right, and then everything else out here are those rain bands that I was talking about. And that's just pulling all that moisture in and circling it around. And my weather classes didn't go quite very high. My earth science, that training didn't go that direction. But just observation, again, over the years I've been watching that these things tend to pull weather into them. All right? And I think a lot of that rain that we saw in one of those pictures there, was probably pulled downwards and inwards towards that storm. I know we see it up here. When these things do make it this far, it pulls some stuff down out of Canada. Again, these are just observations, though. Just observations. So as I said, what is a hurricane? Well, a hurricane is a tropical cyclone with winds that exceed 64 knots. All right, you all know knots and you all know cyclones, right? No, probably not. We will define cyclone in a moment. 74 miles per hour. That's something that we can wrap our brains around. I will put these slides up. I know they're not probably at the moment. They circulate counterclockwise in the northern hemisphere. Yes, in the southern hemisphere it is different, but again, our lecture will be North Americano-centric. So counterclockwise. So arguably I could show you a picture of a hurricane and say, oh, what hemisphere is this taking place in? Is this in the up north with us, or is this in the southern hemisphere? We'll go back to that picture real quick and you see what I mean by circulating counterclockwise. So which way does the clock go? The clock goes this way, right? But think about if this was a roll of toilet paper, a towel, whatever, and you wanted to spin it up. It is, you can see then going counterclockwise, okay? Imagine it trying to wrap up paper and which way you'd have to turn it, and that gets us going the counterclockwise. So what's a cyclone? Well, a cyclone is just not quite just another name for a storm. It, again, is sort of specific. Atmospheric system characterized by rapid inward circulation of air masses about a low pressure center. Now, this is not weather class, this is not meteorology, anything like that. And even in, bless you, in earth science, where we do talk about meteorology, I don't get into these lows and highs and all that stuff. I can't tell you how sad it's made me over the handful of years that I've had students come through the door saying they want to go into meteorology and this and that, and I'm like, well, what math are you in? They're like, well, math 1. Okay. How about your sciences? Well, I haven't taken any. Well, your class. Okay. You need to like Calc 4 to do meteorology, fluid dynamics, all that stuff. In physics out the wazoo. There's a huge difference, and I'm not demeaning either of these people, but there's a huge difference between a meteorologist and someone who reads you the weather. Okay. Yes, we use more and more computers these days, but someone still has to interpret the computer models and decide which one is most accurate or potentially most accurate. But a lot of times these folks, standing in front of the maps, they're not quite there. It's a really, really lot of work going into it. So we don't talk too much about the lows and high pressures. That's fairly low-level stuff. But nonetheless, we talked about atmospheric pressure already a little bit in here in the first chapter. And we're really not going to go too much more into it, other than pointing out that in the center of any of these hurricanes, that eye is a huge low-pressure spot, okay? And as we go from the outside in, you're seeing a decrease in pressure, and that's what's causing this rotation. So hurricanes start from really just thunderstorm systems. This is why the weather has to be just so, and why we see these at a certain time of the year, and so on and so forth, because you don't just need a thunderstorm. Like here, one rumbles through in 10, 15 minutes tops, usually 5 minutes. They blow out all, live fast, die young. They blow everything out, and their energy's gone. So these things are over the ocean, so they can sustain themselves a lot longer. Oftentimes, a couple weeks. And then they bump into another storm to say, hey, how's it going? Let's hang out. And then they make a bigger storm, and so on and so forth. So these are all just little storms that group together. Now, you may have heard that there's a hurricane season. It goes until November, by the way. That is because the water needs to be a certain temperature. 81 degrees Fahrenheit, which is pretty stinking warm, okay? Which is also why there's all this doom and gloom about how climate change is making the oceans warmer, and oh, no, we're going to get bigger, better, more frequently. We're still going to see what effect it's going to have. But arguably, we're going to see bigger, better, scarier hurricanes, okay, etc., storms. The water gets warm earlier because it doesn't cool off as much in the winter. The water stays warm longer, and the water gets hotter. Still can't do a whole lot about it falling apart once it gets over land. Once you get off the water, there's no source for it anymore. But that's where we worry about how big it is. Because those rain bands, as you just saw, the rain bands could already be inland before the storm, the source of the storm, is even on land. And then you got to give it time to fall apart. So that's how these suckers can keep moving so far. If you start listening in spring, again, they're paying attention. I don't want to call it fear-mongering, but again, media on both sides here. All right? You're starting to hear, this is the earliest we've ever seen a hurricane. Oh, no. It is something to worry about. Okay? But again, we don't want to totally freak out about it, but keep an eye on it. Keep an eye on it. So hurricane season might be going longer, might be starting earlier. And yeah, that kind of feeds into what they've been telling us. Okay, so I told you in that last slide, there's a mixture of the atmosphere and the oceans. There's a lot of big words on here we don't really need to worry about, so just kind of listen to me. So we want it to be humid. Don't worry about what relative humidity is versus maybe the word you know, humidity. Let's just keep it humidity. Lower and middle troposphere. So that's the upper parts of the atmosphere that we live in. All right. Again, we want these storms. We're talking about wanting to form a hurricane, all right, in this conversation. We want these storms to linger. So what do you need to feed those? Well, you need lots of water, right? So we want nice, in addition to being over the ocean, we want nice humid air as well. Why? Because that reduces the amount of evaporation. Another big scary word, latent heat. All right? Don't worry about that, but do you remember that the phases of matter, right? When you change phases, sometimes you're storing energy, sometimes you're releasing energy. It's all connected in there. Like I said, meteorology is tough. So these things are building up energy too. Weak wind shear, what's that? Well, think of that as an eraser. It's a horizontal wind, a wind blowing just like you expect wind to blow, you know, from left to right, right to left, east to west, whatever, horizontally. Why? Because we don't want the tops of these storms to keep blowing away. So we want to have low upper level winds. It allows these things to grow into those thunderheads, if you would. Big anvil-shaped clouds you might have seen. But on a totally different scale. Also, that energy that is released doesn't blow away. It stays right there. So, you're with me so far. We need warm water. We need humid air. And we need not so many upper level winds. 3 things we need so far. And if that can all happen, we get to go through all of these stages. We might have talked about this briefly the other day, just anecdotally. You wonder, all of a sudden you hear about hurricane, I don't know, we'll say Nancy, something in the middle of the alphabet, and the last time you heard about it, they were on like George. And you're like, all right, what happened to all those letters in between? Well, they name it at stage 3 there, at tropical storm. They get a name. And it does go alphabetical. But you don't always hear about the storms. You will tend to mostly hear about the hurricanes, unless it's threatening some area that we love. You know, God forbid it goes near our oil fields or something like that. It'll be, you know, you'll hear about it if it's a depression. I still chuckle to myself. It was a really poorly written headline once. Something to the effect of, depression increases, becomes Carl. And it's just like, oh, poor Carl. I feel so bad for him. But what they were trying to say was it had moved from a tropical depression into a tropical storm. But it was, yeah, some new person writing that day. Okay, I really need to update my radar images one of these days. I used to watch the Weather Channel when it was just a radar feed and like teleprompter text. So I've been a weather junkie for a long time. So this is from 95. And I wasn't teaching in 95. I was teaching by 98. But, so yeah, so this wasn't so outdated back then. But now that it's 2024, I suppose it's... Anyhow, Tropical Storm Jerry, right? He can't be too threatening. And we got Iris and Umberto. And again, going back to, you know, what we were talking about, these don't look like a whole lot. Now that you know to look for the commas, the apostrophe sort of looking thing. But look at that tropical storm in the upper left-hand corner. That looks way more comma-shaped than these things are labeling actually hurricanes. And there's a couple things happening there. First of all, just the storm isn't intense enough to be a hurricane yet, even though it's got perfect rotation. And then what I was telling you about how it pulls stuff into it. Okay, so I think these two that they've got labeled hurricanes, especially the one on the right, all right, that's just pulling in clouds from both sides and from the north and the south, if you would. And I think it's just sort of obscuring that rotational pattern, at least at this level. This is a lot like telescopes, where, depending on what kind of wavelength you're looking at, you can see entirely different things. You've got X-ray scopes, you've got, visual light spectrum scopes. They've got, I always wondered as a kid what a radio telescope was. Well, let's hit radio wavelengths, and stars emit at almost all levels of the spectrum. So if you look at it with different eyes, it's like putting on 3D glasses or something. It gives you a different view. So when we look at radar versus satellite, which is the switch I made on you when I was showing you pictures in the beginning, oftentimes you see an entirely different setup. All right, so anywho, let's walk through these stages here. That was almost not good. So tropical thunderstorms have come together under the right conditions. They could organize into a tropical depression. Winds in the center are constantly 23 to 39 miles per hour. And again, out in the middle of the ocean, that's not a huge problem. That comes over land. Well, again, depends if they're used to that or not. 25 to 30 to 35 mile per hour winds come swooping through Utica. It's a different story. One student once, he didn't exactly argue with me, but he was kind of like, well, why are we talking about this in geology? What's the relevance? What's the point? And I didn't have much of an answer for him, short of, well, it's all earth science. It's important. I suppose he wanted to hear about how barrier islands could become rearranged through hurricane action, and that's totally true. That's why it's really not good to develop land on sandbars, where we all love to go for vacation there. But one thing, and it took me a while. I was actually watching some footage of a storm, and we could totally talk about evolution, which is geology, with hurricanes. We just talked about the wind up here versus the wind down there. You ever watch a palm tree? Palm trees are meant to bend. They're leaves. They don't have branches. They got these big flowy leaves on top. I watched a palm tree bend practically to the ground and then just go right back up as the gust left. And it was just still doing its happy little palm tree thing there. Okay, like those big red wiggly guys they have outside of the car dealers and everything, where they're just waggling at you. Try doing that to a maple. Okay, so these trees grew where they, sort of meant to be, where they can tolerate, so on and so forth. It was amazing, just the way it sprung right back up. I'm sure they can snap, don't get me wrong, but totally different. All right, so back to depressions here, a little tangentiation. So we see a low pressure and some circulation has started. Okay, nothing huge. I'm not going to ask you guys to define these. Please don't worry about that. You should know the order in which they occur. There's a depression. So you see how it is starting to comma shape. It is starting to come together. So the next step is a tropical storm. This is mainly kicking up wind speeds. Okay, right now, 40 to 73. That's a huge spectrum. Huge spectrum. But again, typically not too worried about it because you're out over the ocean for the most part. And, if a tropical storm hits land, again, there's not a whole heck of a lot of difference between 70 miles an hour and 75 miles an hour, okay? And that's really, I'm rounding a little bit here, but geologists round. That's your difference at the far end between a tropical storm and a hurricane. You have to pick a line where it switches. But in all realities, is there much of a difference? So you're going to see the storm become more organized, of course. We're trying to form a hurricane. It's going to resemble a hurricane even, but just not fast enough winds is what it boils down to. As we said already, once it hits storm designation, we give it a name. I think the naming stuff, a couple slides about that comes later. And there's Charlie. I've still, for all this time, been trying to figure out what hunk of land we're over. No idea what those black lines are. Okay. So, we haven't touched about it too much. We haven't given you pressure values, but we're trying to build up that low in the center. Okay? That low pressure becomes sort of our spoke for this wheel that is spinning. Primary difference here is that we've hit that wind speed. And again, that wind speed, I don't know if you know or not, okay, wind is just air moving from high pressure to low pressure. Okay, that's air masses. That's what wind is. The bigger the change, the faster the wind moves, the air moves. We call it wind. All right. So there's certainly some numbers of where we could talk about highs and low pressures, but it's most folks and all those category things, they're all based on miles per hour. But the meteorologists, I'm sure, they've got charts, and it's probably based on whatever the pressure is, standard pressure where they started, versus where we need to get to in the middle to get that speed of 74 miles per hour. It's variable. There we go. There's another pretty one, not named for some reason. What hemisphere? We're still wrapping. This one's a little harder to tell, but go to the outer thing and we're going this way. So we're still in the northern. Still in the northern. Oh, how did I mess this up? Huh, won't switch. All right. So we got maybe a diagram to name on the test. All right, you got the eye in the center, that thick donutty part around the eye that I pointed out a minute ago. You'll see another diagram in a moment, don't worry. That's the eye wall, okay? And that is the worst part of the storm. The eye is actually the calm. They say the calm in the center of the storm and so on and so forth. That is true. I'm going to tell you in a couple minutes, never trust that. You'll see exactly why. And then the rain bands. So we've got only 3 things to label on this diagram, should you get it. Okay, the eye wall, and the rain bands. You're going to see all of these words again, so I'm going to switch screens. Forgive me. So we zoomed in on some random picture here, and there's our eye. The eye is the most recognizable feature. Don't worry about their diameters. Okay. As you've heard since you were a little kid, okay, this is the calm in the center of the storm. In every movie, this is where somebody runs out to find their lost cat or their dog or to see how much damage there is. And yeah, arguably at that moment, you are totally, perfectly, undeniably safe. However, you just went through the worst part of the storm, and guess what's coming up next? The worst part of the storm. Exactly. Okay, and you don't know how big that eye is. So the eye wall is the worst part of the storm. I should maybe start with that slide, and you're going to go right back into the worst part of the storm. So please, if you ever find yourself in this situation, and for some strange reason you remember us sitting here and talking about it today, do remember that. Okay? As I told you before, this is sort of your axle. This is where the rotation is, and it's the lowest surface pressure, accordingly. Okay, the eye wall, that's that donut there, kind of hard to see, I suppose. Most damaging winds, the most intense rain. So there's not a whole lot of mad scientists left in the world. There's a few in various things. Probably we're still making Frankenstein somewheres. But I think it's mostly gone down to the microscope and genetic level now. Instead of making large monsters, we're making small monsters. But meteorology still has some crazies in it, thank goodness. And it's because of folks whatever enough to chase storms. We just had twisters come through in the movie theater not too long ago. I did not see it. I did not see the first one. But there are folks like that out there. Okay, and believe it or not, there's folks now that now we're getting into drones, which is, kind of thank goodness, I suppose. But there were folks crazy enough to fly up over hurricanes and drop down into the centers of them. And I don't know a whole hell of a lot about flying, but I'm guessing hitting that low has got to do something funky to your steering. But at any rate, it's because of them that we can get some amazing pictures like this. So this is the eye wall. That's some really dense cloudage there. And here it's down even a little lower. They're inside of it. Now maybe they waited and came up through the center. I'm guessing they flew in and dropped down though. Because again, they would have just, passed through the worst part of the storm. I'd like to think that their vehicle was, safely put away somewhere, but who knows?
You could give this photograph to me and say this is Nordic glacial strata, and I would believe you.
I'll keep that in mind. We'll keep that in mind. So imagine, like I just said, dropping down into the center of that, or flying up through the center of that, regardless. So this isn't here for that reason. This is to reiterate our conversation now that we just had. Come on, Mousy. Eye wall. And we haven't talked about the rain bands yet, but rain bands. So these radiate outward from the eye wall. They are banded structures. There's a couple different words that I use rain bands. Different people use slightly different terms. You might see storm bands or something like that. But there it is, storm bands. But I go with rain bands. So you got to think about this from a cross section. All right, imagine, as I said, well, actually I didn't say it yet. I think it's the next slide, but it's a whole lot of words up there. So I'm just going to talk about it instead. What you want to picture is you standing in one place in this storm system that we just showed you moving over you. All right, so as the rain bands approach you, you're going to get some heavy rains and maybe some wind, and then it's going to stop, and then you're going to get some heavy rains and probably a little longer, some stronger winds, and then it's going to stop for even shorter, and eventually there won't be any stopping, and the storm's just going to build and build and build. You hit those eye wall, that is the worst part of the storm right there, and then all of a sudden, literally, blue skies and sun you could see, okay? It is like a toilet paper tube right through the center of that thing. Then it passes over you, and you're immediately right back into the worst part. And then I suppose from that perspective, it does start to peter out, but it takes a while. And then remember, you're in the outer parts of the rain bands, so you'll see the gaps in between the storms, in between the rain, lengthening this time as it flies over you. So it's pretty easy to picture. And like I said, if you want to read it later, when you print out these PowerPoints, or at least download the PowerPoints, there it is textually for you. Not a whole lot new here. So this is out on the ocean, and they can bang around out there for some time. Generally, I would say they bounce around a lot more as tropical storms, but certainly you can see, and I'm picturing sort of like a pinball ball bouncing around inside of a thing here. They do kind of move around, not bouncing off of islands, thank goodness, but almost. But once they do hit land, or far enough north or south if you're in the southern hemisphere, cooler water, they can fall apart very, very quickly. These things need a constant supply of energy, be it warm water or actual energy. The Saffir-Simpson scale. You never hear that make the news, but you've obviously heard the Cat 1, Cat 2, Category 1, Category 2, Category 3, so on and so forth. This is these guys. Okay. 1 is the lowest. 5 is the worstest. Back when the world was still reeling from Hurricane Katrina that hit in Louisiana 20-some years ago, and things were getting pretty bad. We had a couple bad ones. There was talk of making maybe we need a 6, and it didn't take. Again, that was probably more media than scientists. When we talk about what happens at these levels, you'll see that why there's really no need for a 6. 5 is sufficient devastation. Oh no. I never added my silly cat picture into this one. I love that meme. I don't know. I probably get different memes than you guys. But it's a big white fluffy cat with different stages of hair flying out everywhere, and it's Cat 1, Cat 2, Cat 3, Cat. I'll try to find it. Very funny. All right, so Category 1. These are primarily wind speed based, but you're also going to see something called storm surge. Now, here's the difference, okay, between storm surge and tide, because if you've been to the beach, you know what tide is, okay? And even if you haven't been to the beach, you probably have a pretty good idea what tide is. So tide, just to be sure, is you go to the beach and you set up and you put your lawn chair, just right here, we'll say. And then, depending on what time of the day this is, maybe 3 hours later, what was right near the water for you, the beach, the zone there, the splash zone, is now 10 feet farther out or 10 feet further in. Your chair is now underwater, okay? That's the tide. It moves in and out more or less horizontally. That is not what we mean when they talk about storm surge, when they say 4 to 5 feet. That's not 4 to 5 feet past tide. Storm surge is vertical. So what you have to do is still picture yourself on that lawn chair at the beach chair, I guess, not a lawn chair, and then stand up and find 4 to 5 feet on your body. Then turn around and look inland. And anything that is below that will be covered with water. That's 4 to 5 feet of storm surge. That's that much water raising that high and going as far as it possibly can. That's why we like dunes. Okay? And that's why we shouldn't put our condos right on the sandbars. Because those are Outer Banks. If you've been to Outer Banks, if you've been Jersey, down South Jersey, out there, those are all just glorified sandbars, folks. I go there myself. Don't get me wrong. I don't own property there, though, because, I could put my money elsewhere, right? But yeah, it's not a good idea. All right. So Cat 2, not too big of a spread here, about a 15 mile per hour spread. We jumped from 95 to 110. at the high end. Storm surge is up to 8 feet. So, again, pretty far inland. Think about your boardwalks that you've been on. Like I said, let alone if you've been lucky enough to stay at a hotel or a condo right on the beach. You wonder why houses oftentimes are on those big pillars, telephone pole looking things. This is why. You know, the car gets washed away. Well, it does, unfortunately, but better that than your house, and you certainly don't have basements. So you lift up the house and let it wash under. Cat 3, jumping from 110 up to 130. 130 mile an hour winds, and this is a medium-ish. We're in Cat 3 out of Cat 5, so we're medium to high. Storm surge up to 12 feet. Now you're into town at the t-shirt shops, for sure, even if you had some dunes. Up to 155 miles per hour now. Almost 20 feet high of water. Yeah, what's up?
Storm surge is the one where the tide goes away very, very quickly.
Well,
Is that?
that's tsunami probably, of what you're
Okay.
thinking of. And there's, yeah, and that, I mean, yeah, that's tsunami.
Comes back in.
Yeah, and again, thanks to cameras everywhere, there was really one famous one somewhere over in the coasts along Asia. I don't know if it was in India or farther east. And all these condo, everyone has the cameras now. And it went out. And silly people, and I probably would have been the same too. What the? Huh? That confused dog look. So we just wander out. You can go out farther than you ever had been before. And then it just keeps coming. Once it comes back, and it comes and comes and comes. And it just, whoop. But then you read the reports. Every other animal, we're an animal, that wasn't tied down or could break its chain, left and ran. We're the only silly ones standing there in the mud puddle wondering where the water went. So, yeah, we'll talk about it a little bit when we get to earthquakes. We cover tsunamis. Similar, a similar effect when that water comes in like that. But so Cat 5, over 155 miles per hour, over 18 feet of storm surge. And, even if you engineer for this kind of stuff, there's not a whole hell of a lot out there that can withstand, over 155 mile per hour winds. On these islands where people are buying islands and putting gajillion-dollar houses on them, there are engineers who are working on this kind of stuff. All right, you want a nice niche, and you want to be an architect and/or an engineer. Hurricane-proof housing make you a lot of money. Or even production if they're going to need parts for those houses that they design. All right, but for right now, we don't have much of anything that can withstand this, which is why, as I foreshadowed a little while ago, there really isn't a need for a Cat 6. There's no point. I suppose if we get a 200 or come through one of these days, God forbid, maybe. But Helena, I forget what her name was. What's today's? Helene? I think. Is projected to be a 3, maybe a 4. All right, they haven't seen a storm like that in a while. If it hits that 4, it depends again if it's on the low end or the high end. Either way, that's tough. A lot.
Any idea when we last saw a 5?
We'll get there. So what we consider intense bad is 3. Okay? And I said something somewhat erroneously a couple minutes ago. I said, we're only halfway there. Cat 3 is not great. I was joking about the Floridians earlier. Cat 3s, they tend not to go anywhere for, though. Seriously. So to answer your question, there have been only 2 Category 5s that made landfall the mainland U.S., the Keys in 35, and Camille. Camille is, Keys is not the name of one, and Camille in 69. Maybe we weren't naming them in 35. Opal and Fran, 95 and 96. And as I said, there was Katrina as well. So there's some other words, depending on where you are, where you're from. You might have heard of a typhoon. That's just what they call hurricanes in the Pacific. Okay, in certain parts of the Pacific, I should say, North Pacific. Cyclone, same idea, just a different part. So typhoons, cyclones, hurricanes, all the same idea. And again, I'm not going to ask you where they call it. I'm not about that kind of detail. Don't worry about that. Let's give you an idea here. As long as I've been paying attention, we've not had one hit California. And I assume that the ones I'd heard about in Central America were, and or Mexico, were on the East Coast. But we do have the hurricane thing there on the West Coast of North America.
I wonder if there's a correlation between direction of the hurricane's path and the rotation of the Earth. I think there is.
Oh, I'm sure. Deal with Coriolis effect and whatnot. But you got ocean currents, I think. The Coriolis is going to give you the rotational kind of thing going on. But as far as the path, I don't know.
They'll start at around the equator and then they go west.
Oh, I get what you're going with that. Yeah. And which way do we rotate?
Clockwise? If you're looking down at it,
I'm trying to picture them. We go east to west, right?
Yeah.
East gets the sunrise first, west gets the sunrise last. So we're turning to the east. So that would support your hypothesis. I was trying to picture how that would be clockwise or counter. It's not the right way, though. So 53 is when we started naming them. So that's why that 1 in 40 or whatever did not have a name. And as we said, it starts as they turn into a tropical storm. Alphabetical order. They alternate between starting with male and female names. I think in the past it was originally all female, but that didn't go very well, as you can imagine. So we started throwing male names in there, and now it's getting quite international as well. I think they got tired of Jane and Frank and Steve and so on and so forth. So now we have the other countries' versions of Joe and Frank and Steve, and Sally and Susie and whatever. But so yeah, they alternate. And again, that's the biggest thing is people are like, well, how did we end up on Steve? What happened? Last I heard we were at Karen. How did we get there? Well, they were all storms that didn't amount to anything scary for the media, apparently. All right, this is where I pulled this information from a while ago. So, Katrina, that was more or less America's big one, at least our recent big one. It was up to a 5. And I think they're still arguing, some people, as to whether it hit us as a 5. It definitely hit on a high-end 4. I was just asking how old you were in 2011. You definitely probably weren't even then in 2005. It was, and I don't like that kind of, I don't like watching all that negative stuff, so I don't. But it was unavoidable. It was everywhere because it was a disaster, literally a disaster. If you don't know, due to something called subsidence, which we'll talk about at the end of the semester, New Orleans and the surrounding area is basically a big soup bowl. Okay, and they have some walls up around the city for this very reason, but they were old and decrepit, and it basically the water came in and it stayed. It was not good. It people living in, I think in the Astrodome. That's not what's there. Whatever giant stadium was there, there were people living in what was left of that, and trailers for years. It was crazy. It was absolutely crazy. There she is. And again, it's hard to call something, difficult to call something pretty or beautiful or whatever when you know what kind of damage it causes, but good Lord, that's just Mother Nature at, doing what she does. You couldn't have a more perfect sort of thing there. States aren't outlined on here, but you see those rain bands going way up there. And she's only half on the land.
Yeah, that's directly on top of Louisiana.
Yeah. Now you can see the Great Lakes. And this is where I started to think about how this stuff was pulling down from the north. And just trying to join it. Still together. It's supposed to fall apart when it gets off the water. We're more or less, I don't say immune from stuff like that up here. Removed is a better word. 2011, right as the semester was getting rolling, from the Carolinas up through New England, got thwacked. All right. This is down again right off Cuba, but on the other side. Something gets on the other side of Florida and Cuba, you can almost guarantee it's coming up. A lot of times they peter out by the time they hit the Carolinas. But if it makes it to Jersey, it's coming. It's coming. Look at that sucker. Your states are outlined here.
Yeah, it goes all the way up to New York City and beyond.
Yeah. Cape Cod, Manhattan. Yeah, I mean, those are some weak rain bands. I've got some pictures of what weak rain bands did to Utica. But Long Island, there's the word I was looking for. Long Island is just, I don't know if you've been to Manhattan. And, well, I rephrase this. I'm sure most of you have been to Manhattan. If you've ever been to the edge of Manhattan, it's like 5 feet above the water, 10 at a high end. Okay? It's at sea level. And if you go down, the southern end of the island, it is sea level. They're not meant to take in a lot of water. At least a city like that is not meant to take in a lot of water. Moving norther still, you got New York there. We're not quite in the picture. Oh, and then we change to the radar. Love me some radar. All right, so it hit Delmarva, but if you see that, I don't know how many of you get to that part of the world, but that's Delaware, Maryland, Virginia, that sort of little Bay Area over there. Okay, hit a Cat 2, 100 miles per hour. By the time it hit Manhattan, yes, it did make it to Manhattan. It was a Category 1. And then by then, it did peter out. But again, subway system, not meant for that kind of stuff. This was me being a weather junkie on my cell phone, taking screenshots. Where that pin is Utica there? Oh, is that how you said?
Yeah.
Okay, thank you. Oh, where'd the pin go? There it is. So I used to live by Sequoia Creek for 20 years. I lived about, probably less than 100 yards from Sequoia Creek. And I don't know if you know Sequoia Creek or not. Usually you could wade across it, ankle deep or so, maybe shin. But over the years we saw not even a hurricane, but just storms have brought it up higher and higher. They'll tell you that development further upstream was a cause for that. There's probably a handful of reasons, but truth is, the more you pave, the less you get, water can go into the earth. So the more development there is, less infiltration there is, and the more water has to drain into the streams and lakes and stuff.
Pants to be dark and holy cow.
So yeah, that's not the stream anymore. That is the road next to the stream. And 3 houses down from me. We had only been there about 3 years at this point, and didn't really know what to make of this. They came knocking on our door as it came up the street and asked us to leave. My neighbor was still out. He was, looking back 20 years ago, he wasn't that old as I approach his age now. But the old man next door, I said, "Hey, Rex, you leaving?" "Hell no." I said, "All right, I guess we'll stay too." I don't know if he got water on that one. We didn't. It took to the Halloween storm of 19 for us to get water. Sequoia Creek has been very flood-worthy in the news lately, if you didn't know. But boy, they dropped that police line there right at our street. And the Japos have a really probably sordid history of walking in storms. Like I took the one without the baby in it. It was a later storm. It must have been, it would have been Irene. We're all out for a family walk enjoying the rain bands. She's in a little carriage bubble, though. Those things they put on babies nowadays. So it can hit us up here. All right. And this one doesn't look like it's going to come anywhere near us. But like I said, when they get on the other side of Florida there, pay attention to that one. We did get some rain from, I can't remember the name of the last one that came through a few weeks back. We did get some rain out of that one. But generally speaking, the bad stuff needs to come up the East Coast. I'm going to find my cat picture. 30 seconds, real quick.
I don't know much about Sequoia Creek, but we live maybe 10 miles away from the Herring Creek Golf Club. I remember one fall that became a lake.
Where's Herring Creek at?
I think it's down near. It's down in Clinton.
Okay, just Clinton Way.
Yeah.
What do you mean you can't find people?
St. Kirkland Avenue, did you know that?
Okay.
That's actually right off Riscany Creek, which was also swollen, so
There you
that's where
go.
the water came from.
Sorry, this is so worth it. You got to see this picture. Anybody ever been in a hurricane? I kind of want to experience one. Who raised it? So I didn't see a hand go up. Did you? You've been? Okay. So what did you? What did you guys? Did you guys stay? Okay.
So it was like a lot of broken trees, like damaged cars, and stuff.
Okay.
And then the power shut off, and then the generators, like the neighbors had to come over because we were the only ones.
For how long?
Probably like overnight.
Just overnight? That's good. That's good.
Some people were able to go on by generators, but like for some people, the power was kind of overnight.
Wow. Yeah, I mean, Long Island, I've driven out there a handful of times. It's not exactly narrow, but it ain't wide either. So, I mean, even if you're not on the coast, there's not a whole lot inland you can go. Cat 5's the funniest, but... All right, so, at any rate, so, wish them well. If you have any relatives down there, check in on them. Keep an ear to this stuff. For you folks at home, this is definitely, unfortunately, we got something to put on our maps. You guys on campus probably don't know, for my online classes, as one of their projects, we run a natural disasters map. I tried calling it nicer things over the years, but that's in the end what we end up plotting. Be it wildfires, mudslides, hurricanes, volcanoes. Hardly ever get any volcanoes. We get some earthquakes, though. So they plot that stuff it runs an entire semester, and then we throw some plate boundaries on it and try and make a couple connections. But so they keep that up on their wall, or lately we've been doing it digitally. But it started off as a poster map back when I did this. And just kind of point out that earth science, again, is something where we have current events and occasionally need to stop and pause and acknowledge that. I would have done the same thing if there was a massive, God forbid, but if there was a massive earthquake in somewhere in California or something like that last night or this morning. We would stop and we'd talk about earthquakes. So we acknowledge what we can and try to make, as I said, a bit of levity here and there. So, all right, if you guys have any questions on campus or at home, as always, please feel free to ask. And when we come back, we'll pick up where we left off with lecture.